Hey, Vlad here, devinsidy.com. Welcome to another video. In the previous video, we have learned about the basics of the ordered collections, and today we're going to implement lists, learn about the particularities of foldRight, and also integrate lists into our homegrown collections library, which is quite a bit of code to write, and I might even split it into two videos. Let's see. Let's get right to it. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, which is the editor of my choosing, which is fully maximized. And at the bottom, we're running a plugin called Terminus, which runs SBT, which we use to rerun the test every time we save the file. Remember the time when we spiraled down into the whole trampolining series and we were forced to implement a very simple version of stacks? Well, it turns out that stacks and lists are virtually the same. It's just that the operations are called differently. So what we will do today is we will just copy paste stacks, put them into a different file. We're going to call them lists. We're going to rename a few things, and by the end of the video we're actually going to remove the stacks and just replace them with a simple type alias. So let's get right to it. So what I'm going to do now is I'm going to copy stack, I'm going to create a new file, I'm going to save. And by the way, in Sublime, if I am in here in the stack and if I press Control N, it will, and then I save the file. It will, the default folder which will open here is the folder where the stacks were, which is exactly what I want. So if I'm going to create a list.scala over here, and I'm going to right click and say reveal it in the sidebar, it will show me that it's over here exactly where the stacks are. And by the way, there's a new version of Sublime that came out, and because it just created a new file, it thinks that there's a change, and we see the circle over here, and the file is untracked by git, and we also see circles over here because all of these folders were touched now, so to say, right? Because this file is in this entire tree. Okay, so I'm just going to paste it over here. So everywhere where I'm going to have stack, I'm just going to say list like this. And let's just save that. Now, so far, I have been calling our collections exactly the same way as they're called in the standard collections library. And this usually is a bad practice. And as you can see here, everything compiles now, but actually in our tests for sets, we have been using lists a few times. And so now, because we have lists in the homegrown collections, we should be using this list in those tests. It's just that the SBT, the incremental compilation in SBT, did not notice that. So if I actually press enter over here, if I clean and if I run the test now, it will take some time to recompile everything. But essentially, if I'm right, then the tests for sats should not compile. Yep, that's exactly what's happening. So at the very least, we need to have a var args method for list, which will be the factory, and this will solve most of the issues there. So for now, what I'm going to do is I'm just going to switch to compiling the regular code, which should be fine. So in case you didn't watch the trampolining series, and in case you haven't seen the stacks, let me walk you through list, which is just like 26 lines of code, right? So it's a simple ADT, right? So there's a trait list, and there are two versions of it. There's the empty version, which is usually called nil in the standard library, nil, and this one is the non-empty version, which has the element and all the other elements. Usually this is called head and this is called tail, and the entire thing is called cons, and it is usually spelled as two colons like this. Okay, so if I open up list, we should have just a few operations. So we have push and we have pick, pop, which is just a combination of pop element. Okay, so push just pushes an element onto the stack. So in terms of list, this operation will be called prepend. In fact, this is what we're going to do next. And pop just takes the first element from the list. Okay, so it's sort of like a remove. Okay, so what we're going to do first is we're going to start by creating aliases for push. So we're going to have sort of like a combination of lists and stacks, right? That are they're literally exactly the same. Just the functions are called slightly differently. Okay, so what we're going to have is we're going to have a function called add. This is going to be our main function. And so I'm going to do is I'm going to duplicate it 4 times, and I'm going to move this one up there. Okay, and the implementation, let me actually have a cursor over here. I'm going to have at inline. Okay, so all of them in line, right? So all of them they will just call add with input like this, and this one is going to be called prepend. This one is going to be called colon, which is pronounced as const, and this one is going to be called push, as we had before with the stacks, right? So all of this should compile. They just, all of them just delegate to add. And remember, in Scala, every method that is called in such a way that the last character is a colon is actually a right associative method, right? So if we have some list of 1, 2, 3, which we don't have the var args yet, but if we had a list of 1, 2, 3, and if we did dot colon, right, and as an argument we would pass list 4, 5, 6, then it would be the same as saying list 4, 5, 6 colon list 1, 2, 3. In fact, what I just said is bullshit, because I was thinking actually about this method, which is the concatenation of lists, but this one is going to work exactly the same way, right? So this one just prepends one element, right? So we're going to have a 0 over here, and it's going to be the same as 0 colon list 1, 2, 3, just as a reminder. Okay, so let me remove all of that. Let me see if it compiles. Yep, it does. Next thing we're going to do is we're going to do the same thing for peek and pop. So it's basically head and tail, right? Like this, head and tail. And what we're going to have here are aliases. We're going to have inline, final, lazy, val, peek, which is just going to be head. And we're going to do the same thing for pop, which is just going to be tail, like this. Okay, so that's pretty much all the basics. Our pop element just pattern matching on which version we have. So if we have the empty, then we're returning a tuple of none and empty, and if we actually have something, we're returning a tuple of some with an element and the other elements. Okay, so let's start by creating the first test. So we're going to go to set suite, and we're going to do the same trick. I'm going to press Control N, I'm going to press Control S, and it will ask me to save it in the same folder. So I'm going to call it list suite .scala. In fact, let's go back to set suite and just do that, put it over here, call it list. In fact, I don't think that we're going to have a companion object, so we're just going to have that. Okay, and I'm going to create the first test, and I'm going to call it var args. Or in fact, maybe let's type the whole thing. We're going to say calling the var args apply method on the list companion object should yield a list with all the arguments as elements which are appropriately ordered, right? Because we're talking about ordered collections, right? So the first version of this test is going to be list 1, 2, 3 should be list.empty, and we're going to use the stack methods here, right? So it's basically push the 3 first, and then we need to push the 2, and then we need to push the 1. Damn it, my hands are so cold. It's so cold here. All right, so if I save the file now, then it's going to look like as if it compiles. But remember, we're compiling just the source code. We're not compiling the test code. So in fact, let me comment this out real quick, and let me switch to just running the tests. And what we're going to have is that the set suite is not going to compile, as you remember. So what we need to do is we need to go through a few places and fix our compilation errors. Let me create a bit more space over here. So we're going to go to 623. Okay, so one of the issues is flatten, right? So we don't have flatten on our list yet. So what we're going to do is we're going to go over here. In fact, why don't we go everywhere where it says lists? Let me go and see. Yeah, it should be fine. Everywhere where it says list, we're just going to say Scala dot, right? So now it should go to the Scala list, and everything should be fine. Okay, compiles. All right, it's fine. So now if I go back to list suite over here, let's do that. And now I should say, hey, we don't have the var args method yet. We don't have the factory method yet. So let's add it. Let's go to factory, which is over here. And it has already a var args factory for us. And by the way, guys, if this is going too fast, remember that we have more than 30 videos already in the Homegrown collection series. So if you're joining just now, we have done all of that really slowly. So if I go down over here into the list, I can just paste it over here, right? And I can just say that instead of this nonsense, we're just going to have list. And let's see if it compiles. It should compile now, but it shouldn't do the correct thing. Okay, in fact, maybe we should also switch to running just these tests, right? So we can say test only user dot list suite like this. Okay, so oh my god, still not enough space, really? Okay, there we go. Okay, so now as we can see, the order is wrong, right? So we have 3 to 1, but what we were expecting was 1 to 3. Okay. Now the issue here is that we're using fold left on this, right? So this is just a sequence of elements, right? So the var rx method, this is just a sequence of elements, the sequence from the standard collection library. And the standard collection library also has foldRight that we learned about in the previous video and that we will actually implement today, as I already mentioned. So all we need to do is we need to use foldRight, and the way we do it is we just say foldRight, and over here, this empty dot add element, it should happen actually at the end, right? So I'm just going to cut it out and I'm going to paste it in over here, right? So the order is different. And remember that for foldRight, the order over here was also switched, right? So first of all, let me do this. So this is actually ACC current. Hold up, usually it's written over here like this: ACC current and ACC dot add current, right? So this is what we had before, right? So before we had just underscore add underscore, okay? But now for foldRight, these are actually switched, right? So this is the current and this is ACC, so we can't use this this fancy underscore syntax, okay? So let me do this, and now I should actually fix everything. Whoops, fix everything, okay, like this. And remember, because we have now the colon methods, right? So we add is just overloaded a few times and is doing the same thing, right? So we have add, we have pretend, and we have this colon. This is right associative, and this is done exactly for this reason, right? So now I can go over here and I can say element colon colon. So instead of doing dot add element in the end, right? And also for foldRight, I can do the same thing as we just had before, like this. Okay, so I can just do this because now it matches the order, right? So before what we had was this. I should have commented it out. So before we had fold left and we had empty dot add element, and over here we had add, okay, and now we're using the right associative operations just so that we can use this underscore syntax, okay, but effectively it's the same thing, just in different direction. Now, one particularity that you might be wondering about is that in the previous video, which is totally related to this one, by the way, we used foldRight to reverse the string. Over here, we're not actually reversing anything, but we're using foldRight to build a list, and this is happening by convention because remember, lists are stacks, and so when you build a list, you build it backwards, which is actually exactly what our test is showing us, right? So we're building this list backwards. We're putting the 3 first, then the 2, then the 1, and what are we getting is we're getting a list of 1, 2, 3. And also because we already talked about property-driven tests, let's go to list suite, which is over here, and let's also instead of this one, let's also do for all, right? And then we can say, let's say A, which is an end, B, an end, C, which is an end, okay, like that. So we can say list of ABC should be list.empty.add 3 add 2 add 1, and the same thing should happen for prepend. By the way, I have no idea why I used 3 2 1. I wanted to use C, B, and A like this. Also was this syntax, right? So we have ABC should be, and now we can do A, B, C, list dot empty, and also in this case we actually don't need the parentheses over here. So this reads sort of on one hand it's kind of nicely, but on the other hand it's so confusing. Like I've been doing Scala since 2010, which means that I have like around 9 years of Scala experience, and still I look at this and I cannot say with a full confidence that I know how the precedence will work over here. So when you're mixing left associativity with the right associativity of the operators, please, for the love of God, use parentheses. I hate parentheses myself, but in this case it is actually better. So in this case I'm actually going to remove this one, and in fact we actually don't need this one at all. Okay, so add pretend, and we can actually also use push, right? Push, right? So now we're testing all of them, even though it actually doesn't make much sense because they just delegate to one another. So in the previous video, we talked a lot about reversing. So why don't we add the reverse method to a string? So we can say calling reversed on a list should, well, reverse the list. Okay, by the way, notice that sometimes I'm spelling list with a capital L and sometimes with a small l. I'm sort of thinking about, like, when I'm using it in a sentence as a class, then I spell it, with a capital. I'm not sure if it's a convention. I don't know. Somehow I came up with this. In any case, so let's do list.empty reversed. It should be list.empty, right? So we're doing a little bit of TDD here. So in fact, hold up. Let's do just list and list suite and list, because usually let's do it over there. Come on, like this. Okay, so we're gonna have list suite over here, and we're gonna have lists on the right. This is how we usually do it. Okay, so we're gonna go to list, and we're gonna add a function called reverse, right? So we're just gonna go final def oh my god, final def reversed, which is a list of elements, and we're going to just throw an exception over here because I just wanted to compile. Okay. All right, cool. So now we're just going to implement it right away. We're just going to go and say this. Oh my god, what's happening today? This match. Okay, so if it's the empty one, then we're just going to return empty. What's wrong? Empty. And otherwise, if it's not empty, we have the element and we have the other elements like this. Then what we're going to do is we're going to do other elements dot reversed, which is the recursion, and then we're going to have append element. But the problem is that we actually don't have append, and appending something to a list is basically impossible. Appending something to a list basically means rebuilding the entire list, right? Because if you want to put something in the back, we need to put the last element at the front, right? It's kind of confusing to say, actually. In any case, because we don't have appending, we actually have to keep track of our state. So instead of this, what we're going to have instead is we're going to have a tail recursive method, right? So we're going to have reversed, which is going to produce a list of element equals. So what we're going to have is we're going to have a helper method called loop, and it's going to be at scala dot annotation dot tail rec. So we're going to finish it in just a few seconds, but by the end of this method, we're just going to call loop was this and was empty, right? So the loop, what it will take is it will take the current list, right, which is the list of element, and it's going to take some sort of accumulation, and there is a reason why I'm calling these why I'm calling them like this. All right, but we have done this already so many times. Okay, so this produces a list of elements. Okay, so what is it going to do? Well, it's just going to take the current and it's going to match on it, do the same thing as above. It's going to take case empty, then we're just going to return ACC, and otherwise if it's non-empty with the element and the other elements, well, we're just going to do recursion. What does it mean? Well, we're going to call loop, and we're going to say that current is going to be other elements, and we're going to say that ACC is going to be element column ACC, like this. Let's see if I made any typos. I shouldn't. Okay, cool. So now we can actually go back and finish our test, because now in the test we're just testing the empty one, right? So let's go to for all, and we're going to say the same thing. So we're going to do A, which is int. Oh, come on, I need these parentheses over here. Int B, int C, int arrow to the right, like this. And we're going to say that a list of ABC dot reversed should be list of CBA. Let's see, like this. And yep, it's all green. Okay, so let me look at the implementation just one more time. Yep, it's all good. Let's have more space over here like this so that you see the entire thing. Let's actually comment on this one out. There we go. Now, every time you see something that accumulates state and just happens to be tail recursive, think about fold left, not fold right, fold left. And obviously lists are foldable, so we can go over here and we can say lists extends foldable of element like this, and this will force us to implement the fold method. Okay, so we can go over here and let's put it right over here, right? So we can say scala dot annotation dot tail rec, and we're going to have final override, and we're going to go to foldable. Actually, let's open it over here. We're going to go to foldable, this one. Where's our fold? We're just going to copy that, fold like this, and we're going to implement it right away. So we're just going to do this match case empty, we're just going to return the seed, in case not empty, we're going to have element, and we're going to have other elements. And again, if this is going too fast, we have done this so many times already. Okay, so we're going to have current result, which is a function of seed and element, and we're going to have other elements, fold current result, and we're going to have a function over here. Let's see if this is enough. It should be. Okay, yes, this is enough. So now what we can do is we can go over here where we have our reverse, so we can throw it out completely like this whole thing, and we can just say fold list of elements, and we have empty over here, and we have add over here. It's kind of funny that reversed actually uses the fold left, right? Why is this happening? Well, it's happening because, again, we're building lists backwards. So we need fold right to build the list, and therefore we need fold left to reverse the list. And by the way, it's just a convention to build lists as stacks, right? We could have as easily built it in such a way that we wouldn't have the head and the tail, then instead we would have the body and the last element, right? So it would be built forwards, but then every operation would need it to be backwards. It's just a convention. It's been done like this since forever. So we will come back to the folds in just a second. What I want to do is I want to add something to the test, which will force us to create a generator for list, which is something that I want to do. So over here, we can say for all original list of ints, right? And if we do original dot reversed, and if you reverse it again, then it should be original, right? And now it's not going to compile because we don't have a generator for list. So what we're going to do is we're going to go and create it. So somewhere we have the package object over here, where we have the generators for the sets, right? So we have the arbitrary gen and gen for non-empty. And by the way, I made a mistake back then in the video. Well, it's not really a mistake. It just said if we do sys.error should not happen over here, and then it's a bit more obvious, right? Because we're generating a non-empty set, okay, and we're using the non-empty factory, so this case should never happen. All right, so what we can do now is we can just copy this entire thing, paste it over here, and use list. It should be like this, right? Let me double check. Yeah, that should be fine. Let's do list. And I believe as of right now, our empty method actually is not parameterized. Okay, so we can't actually do this. So we can just remove this. Like, I'm going to do this. Now I'm not going to remember to come back here. All right, so this is what we have. So I'm just going to remove it like this. Okay, so now everything compiles. And by the way, this new version of Sublime, it also has the git gutter as part of Sublime. Before I was using a plugin called VCS gutter. Right now we don't need it because it's just built in. So these lines are added, and this line is, for example, changed. Okay, and if I were to remove something like this one, you would see this arrow over here. Okay, let's do that. All right, so now that we have that, we pretty much don't need this. And we pretty much actually don't need that as well. Okay, so now our tests are becoming shorter, which is one of the benefits of property-driven tests that I already have 2 or 3 videos about actually. All right, so what I want to do from now on is actually start using fold left instead of just fold, because now we're going to have fold left and fold right, and I want to make this distinction a bit more clear. And if it's going to take forever to rename, then I'm just going to cut it out from the video. And by the way, this is one of the cases where a proper IDE would actually be useful. And the problem is that I have never used IDEs on my channel yet, and until I'm going to make videos about them, I'm not going to start using them. And so I'm just going to start refactoring. So I'm just going to rename fold to fold left, right? So I'm just going to go to foldable, and I'm going to say everywhere we have def fold, I'm just going to replace in my entire project, everywhere where I say def fold, I'm going to say def fold left, like this. Okay, and my face is actually covering the replace button, so I'm going to do this: replace 7 occurrences, 6 files. Yes. Okay, so I'm going to go and I'm going to change all of this, and if this is happening too slowly, then I'm just going to cut it out from the video. Okay, so for now I'm just going to go here, I'm going to say save all, and it should generate a bunch of error messages. Yeah, like 23. All right, so it seems like I got all of them. So let me just close all the other ones. So we just have list again, and we have the list suite, and let me close the other ones like this. So what we're going to do is we're going to go to foldable, which now doesn't have fold, it has fold left. And as you can see, the changes over here and over here, right? Fold left everywhere. I'll scroll down, fold left, fold left, fold left. Okay, so what we're going to do is we're actually going to add fold right. Now, foldable, so a collection like set, right, that we have been implemented since the very beginning, it actually extends foldable factory, and foldable factory extends somewhere, it extends foldable, right? So even an unordered collection can benefit from fold right, which is why we're going to add it right here. All right, it's going to be fold right, and remember the convention is to swap these two, right? So this is going to be the element, and this is going to be the result. Now, I don't want to go and implement it everywhere, so for now, I'm just going to throw an exception over here, right? For now, it should be fine like this. Okay, this is foldRight. And also, by the end of this video, we're going to improve the signature of foldRight a little bit. So this is not the final signature. So what I want to do now is I want to improve the toString implementation before we're going to go to foldRight, because it's just going to make our tests a little bit easier. In fact, what I'm going to do is I'm actually going to copy paste the tests that I have for them. So I'm going to copy paste the tests like this, like that over here. So what I have is I want our list to be rendered like this. I want it to always say HGC, which stands for Homegrown Collections, not for the Haskell, Glasgow compiler or whatever, right? So it stands for Homegrown Collections, and so it's just gonna render like this. Okay. So this is what we're going to do. We're going to go to list, and we're going to implement toString somewhere down here. So we're just going to say final override def toString. In fact, today we're going to improve the implementation of toString for all of our collections, right? So we're going to use string interpolation over here. We're just going to say HGC list, okay, and over here we're just going to say toString content, and toString content is just going to be a private def over here. In fact, it's a private this def. It's going to be called toString content. I'm going to produce a string. We're going to do this match. I'm going to say case empty. Then we're going to have an empty string. Otherwise, if it's a non-empty with an element and other elements, then we're going to use string interpolation over here again. We're going to do element, and we're going to over here, I'm going to do split by comma space other elements. Okay, so split by comma space is the method that we have been using quite a bit. So we have it in map and we have it in set. So I'm going to go to set, and I'm going to go like this. I'm just going to copy it out. I'm going to paste it over here, and it uses a tree. In fact, I'm going to use foldable over here like this. Let's see if I made any typos. I didn't. So this is the implementation that we have already implemented for sets and for maps. They're all pretty much the same. In fact, what I'm going to do now is I'm going to put the split by comma space function into the foldable trait. So then I will be able to say other elements dot split by comma space. So I want it to be defined all on foldable, right? So the input is going to become effectively this. Okay, so I'm just going to also say that it produces a string, and it's not going to be private this. It's going to be protected maybe. Let's just make it a final def for now. And just make it a final def. I'm going to cut it out like that. I'm going to go to foldable somewhere at the bottom, somewhere over here. I'm just going to put it down over there. All right, so we have a comma space. So now what we can do is we can go to set, and we can actually improve the implementation a little bit, because it's because I did it a little bit the other way around, but now I wanna make sure that they all kind of remain the same. So instead of this, I'm going to do the similar trick. So I'm going to do this. In fact, let's do this. Let's do HTC set. Okay, I believe that's going to be better. HTC set like this. So all of these collections are rendered like HTC something. Okay, so we're going to have toString content, right? And we're going to do this, and we're going to do private this. It's not an override, and now it's called toString content like this. And what is it going to do? It's going to match on the tree like this, and if it's empty, then it's going to produce the empty string, and if it's not empty, then we're going to use string interpolation over here. So I'm going to leave the other one like that for a bit. So I'm going to use a string interpolation, and it's going to be the same as before. It's going to be element, and now we're going to do left dot split by comma space, and we're going to do the same thing with right dot split by comma space. But over here, just gonna remove that, and we don't need this split by comma space like this. I believe this should be fine. Let's see. Oh, I forgot actually to run all the tests. There we go. We're running all the tests, because now they should fail because we changed it to toString implementation. Okay, so let's go to set suite. Let's find toString somewhere like this. No, not this one. And there we go. Okay, so this should be HTC set like this. So let's see, does it go down from 4 to 3? Yes, it does. Okay, this one is okay. Let's create a bit more space. This should yield, no, this should be HTC set of element like this. So it's going to be HTC set of element like that. Okay. All the others. Okay, so we can probably do this like that, this like that. Let's see. All right, only one test, which is probably which one is it? Two elements should contain two braces, blah blah blah. It's probably this one, right? Two braces. Okay, let's see. 719. Hold up. That's over here. Okay, so it's this one. They code very similarly. There we go, like this. All right, so that should be fine now. Let's see. Yep, it's fine. Okay, let's do the same thing for maps. Let's go to map.scala. What do we have? ToString. We have ToString over here. All right, so same trick. Let's go down like this. Let's use string interpolation over here. Let's do HTC map, and we're gonna have ToString content. Close it over here. So we're gonna have a private this def ToString content, which is a string. So over here we're just going to do this, and over here we're just going to have an empty one. And over here, instead of using string interpolation, we probably are going to use just that. So whoops, I pressed page up all of a sudden accidentally. All right, so we're going to have format off, and we're going to have this, and we're going to have that, and we don't need this, and we're going to have format on over here. So what's happening here is that we have this function called unsafe rendered, and this is the one that is called by split by comma space. It turns out that we actually don't need that. We can actually do just left.map unsafe rendered, right? And now we can just say split by comma space. Okay, and we can do the same thing with the right one. Okay, so now let me join the lines, and let me just do this. Let me have this over, let's do like that. Okay, that should be fine actually, and we don't need this. Let's see. All right, something is not fine. There's a plus over here. We don't need this plus, like this. All right, it's fine. So now we just need to fix the tests, which are over here. All right, let's scroll up, and it's 558. So this now says HTC map, and this one says also HTC map, like this. Okay, there we go. Everything is green. Cool. All right, so I'm sorry for this excursion. So let me close everything over here, and let me close this over here. And the next thing that we're going to do is we're going to add a method for concatenating lists, right? So we had union for sets, and over here we're just going to have concatenation. Okay, like this. So what we're going to have is we're going to have list.empty concatenated with list.empty. Should be list.empty, and obviously we don't have this method yet, so let's go and edit. So we're going to go down over here. Let's go and say, in fact, let's put it under, somewhere under full left, somewhere over here. Let's do it over here. Okay, so we're going to have a final def like this. We're going to have this covariance stance that we have been doing for so many videos already. So we're going to have list of super. Let me create a bit more space like this. Whoops, wrong braces, like this, super. And what we're going to have is a list of super over here, and we're going to see that what we need is actually foldRight, right? So we haven't implemented foldRight yet, but that's exactly what we need. So I'm going to have list of super. I'm going to have this over here, and we're going to have that over here. Now we don't have foldRight yet, and therefore we're gonna see a thrown exception over here. In fact, maybe we can switch back to running only the list suite, user.list suite, like this. Okay, so now we see one test failed, and we see the not implemented error, right? Because foldRight right now throws an exception. Okay, foldRight throws an exception over here. So we're going to implement foldRight in a second, but let me finish writing the tests first. So let me go over here, and let me just write. Okay, so let's say we have left, and let's actually also do format off. So let's do list of AB like this, and we're going to have right, which is a list of CD. And in fact, let me do this. Hold up. It's going to look cool. So we're going to have list of something like this, list of CD. Okay, let's actually have this brace over there. Okay, so this is B and this is C. So if we had a comma over here, it's going to look like that. I think that's what I want, like this. Okay, and the sum or the concatenation is going to be list of A, B, C, D. Yes, I was right. Cool. So what we're going to do is, if we have left and we have list dot empty, well, then it should just remain left. And we have list dot empty. I'm going to have right, then it should be right. And if we have left and right, then it should be sum. And let's actually do this and that like this. Let's also move the should be like this. Okay, so all we need to do now is we need to finish the format on like that, and we just need to wrap it into the for all, right? We're gonna have A int B int C int D int like this, arrow to the right, bring this brace down and move all of this one way to here. Okay, so I just want to see if it compiles. It should. Yep, it compiles, but obviously it still throws the exception. All right, so let's implement foldRight, and we're going to take it slowly with foldRight. We're not going to take it slowly with the implementation, but after this, like once I finish typing it, we're actually going to move really, really slowly and see exactly how foldRight works. Okay, so what I'm going to do is I'm going to do that, and I'm going to go over here. I'm going to say final override paste foldRight. Okay, so foldRight just does the same thing as fold left but in reverse, and therefore the implementation is also going to be just the mirror of fold left. So in fact, if I just copy that, paste it over here. So if you look at this, we see that what fold left was doing was it was calculating something while it was traversing the list. Fold right should do the opposite. It should traverse the list first, and then once it goes back, it should actually do the calculation. So as you can see, the first line in fold left is calculating the result. Well, it should become the last line. Okay, so the first thing that should happen is that the other result should be computed. The other result should be computed. Well, how? We have other elements. We have foldRight. It's going to be foldRight now. We don't have the current result yet, but we have something of that type, which is seed. So we're going to use seed over here. So the first line is actually finished. And the last line is actually almost done, right? So we're just going to return the current result. So we don't need this. All we need to do is we need to switch the first of all, we already used the seed, so we're going to use the element over here. But remember, foldRight and the function of foldRight, these are swapped, right? So we just need to swap these. So so now it says element, but it actually should say element and the other result. Okay, so over here the function was called with seed and the element, and over here the function is called with element and with the other result, because seed was used in the calculation of other result. Okay, so let's see if I made any typos. I didn't, and our test is also already green. So what we're going to do now is I'm going to show you how to visualize that a little bit so that you actually understand a bit better what actually happens. So what I'm going to do is I'm going to comment this out, and I'm going to call another task. I'm going to say concatenation tracing. Okay. So what I'm going to do is I'm going to have a print line first with my favorite hyphens \u to 500, right? And this time we're going to have 100 of them. We're going to have them twice. So over here, what I'm going to do is I'm going to do list 1, 2, 3, concatenated with list 4, 5, 6. Should be a list of 1, 2, 3, 4, 5, 4, 5, and 6. Let's save it, and let me also copy that, my favorite hyphen, and I'm gonna paste it over there like this. All right, cool. So we're gonna go to the we're gonna go to the concatenation method, which is over here, and what we're gonna do instead is, first of all, we need even more space. Okay, so we're gonna do this. And you know what? I'm just gonna I'm just gonna do this. I'm gonna print out this aka seed, okay? And I'm also gonna print out that, okay, like this maybe. Okay, let's see this. Let's see this. All right, so we have this is 4, 5, 6, which is also going to become a seed in foldRight, and we have that, which is 1, 2, 3, because remember this is a right associative method, right? So this is the this, and this is the that. Awesome. Okay, so now we're going to go to foldRight, and we're going to do this. We're going to say this is going to be the result, and what we're going to do is we're going to return the result. And in between, we're going to have a fancy print line so that we can trace what is actually happening. And what is happening is that we have the element, which is going to be $element, and we're going to have the, whoops, I forgot the S. There we go. We're going to have the other elements, which is going to be $other elements, right? And then we're going to have a tab, and we're also going to have the result, which is colon result. And let's see. If we scroll down, this is the tracing. All right. Oh, come on, don't jump. All right, so as I already said, foldRight, the first thing that it's doing is it traverses the whole list to the end, and then on its way back, it applies this function, and it applies the print line. So the first print line that we see is the last element in the list, which is 3. And in this case, the other elements, why did I call it other elements? It should be called other result. Hold up, like this. That's what I wanted, other result. Okay, so that's what we have. Okay, so the first element that we see in the print line is the last element in the list, which is this 3. And at this moment, the other result is just the seed, right? It's just a seed, and the seed is 4, 5, 6, right? So what is it going to do? Well, it's just going to the function that we're passing is just the append, right? So if we go to here, the function that we're passing is just the I'm sorry, prepend. It's just a prepend. So all it's doing is it takes this 3, prepends it to 4, 5, 6, right? So now in the next iteration, the other result is going to be what we have over here, right? The 3, 4, 5, 6. And what is the element there? Well, it's the second to last element, right? It's the 2. So we're going to have 2, 3, 4, 5, 6. And then the first element is 1. So we're going to have 1, 2, 3, 4, 5, 6. This is how foldRight is happening, right? So it traverses the list, and on its way back, it actually applies the function. And this is also the reason why it cannot be tail recursive. All right, so let's now get to an important part. We're going to implement a function called takeWhile, which is very, very similar to the function called filter that we already have implemented in the past. In fact, let me open filter in the foldable factory. We actually have the filter function. Okay, so we're going to implement the function called takeWhile, and it's very, very similar to filter. But what filter needs to do, filter needs to touch every element in the list, because the very last element might still satisfy the predicate, and therefore we might need to return it. Whereas takeWhile, it's going to traverse the list until it finds the element which does not satisfy the predicate, and at this moment it's going to stop, and it's called an early exit. So it will exit early, and therefore it doesn't need to touch all the elements. So if we have, for example, a list with 1 million elements, and all of them are ordered, and they start with 1, so it's 1, 2, 3, 4, 5 until the million, and we say takeWhile, and the predicate that we pass in is, okay, give me all the elements that are smaller than 3, then it technically needs to do only 4 operations, right? It needs to look at the 1, it needs to look at the 2, it needs to look at the 3. Let's say the predicate was less or equal to 3, right? So it looks at 1, 2, 3, then it looks at 4, it sees that it doesn't satisfy the predicate anymore, and it should stop. So we're going to implement takeWhile, and we're going to see how foldRight is going to help us to implement it. Okay, so as always, we're going to start with a test. So we're going to go to list sweep, and let me comment this out like this. Okay, and also let's comment out this tracing. For now we don't need it, and in fact we actually don't need we don't need this, like this and like that and like that. There we go. Okay, so we're gonna have takeWhile test takeWhile. Okay, and we're just gonna have a list, which is a list of 1, 2, 3, 4, 5, 6. Okay, and again, imagine that this list has like a million items. Why is Scholarify not working? Somewhere, do we have a comma somewhere? No. Scholarify has something that it doesn't like for some reason. Hold up. Let me clean. Let's do that. I'm going to cut it out from the video. There we go. Okay, so we have this list. Okay. So now what we're going to do is we're going to do format off, which doesn't seem to work all of a sudden. I don't know why. I'm probably missing something. Maybe you see it, but I don't. Okay. So the first one that we're going to do is modulo 2. not equals 0, right? So this is basically is odd. So basically give us only the odd elements until you encounter one element that is even, right? So it should go from here. It should see 1. It is odd, so it should give us. Then it's going to look at the 2 and it should stop, right? It basically is going to say, hey, the predicate is not satisfied anymore. Okay. So the next one is going to be a list take while smaller than 3, right? Like this. Should be list of 1 and 2, and this one is just gonna copy that, so it's just gonna be like that, like this. All right, so and this is going to be a list 1 2 3. Now what's going to happen is that this test is going to be green, but it's going to be green. It should be actually green. What's happening? Okay, so this is actually what I was about to explain, that what's happening over here, that if I do Scala dot over here, what's going to happen is that we have an implicit conversion somewhere in foldable. In fact, let's open it. So if we go foldable, somewhere at the bottom, we're saying that view from foldable to traversable, right? So we have an implicit conversion that converts every foldable to a traversable, right? So what's happening over here is that we don't have take while yet. So the compiler looks at this and converts it into a traversable, and the traversable has the take while. And then what's happening here is that what comes out is also the Scala list and not our list. So let's fix it for now like this until we actually have take while. In fact, let's go to foldable factory. Let's copy the filter and let's insert it into the list. Right underneath, actually, let's go and insert it over here, and I'm going to call it take while, and this is going to be list, and this is going to be empty. Now obviously this is the wrong implementation, right? It's the filter, but at least now we can go back to our test and we can say that we actually mean our test, right? So now it should fail for the appropriate reason. It's going to say 531 was not equal to 1. Okay, so now we can actually implement it, and it looks like there are two issues. The first issue is that the order is wrong, and we already know how to fix the order, right? So we can just use foldRight. So we can just use foldRight over here. We can just swap these. This is going to be the current, and this is going to be the ACC, right? So now it's going to say a list of 1 through 5 was not equal to a list of 5, right? 1 through 5 was not equal to list of 5. And now what we need to do is we need to implement this early exit by just not using the accumulation in one of the branches. In this case, we're not going to use the accumulation in this branch, but we still need to return a list. So we're just going to return an empty list. And this should turn all our tests to green. And now we're going to trace it so that you see exactly what just happened, because I know that this was a bit too fast. And also I'm speaking a bit faster than usual because I know that this video is going to get way too long. And if it gets like way too long, then I'm also going to split it into 2.